Well, hello, students. Today we're going to be talking about transforming linear functions, which simply means moving it around. A family of function, first and foremost, is a set of functions whose graph has basic characteristics in common. So, for example, all linear functions would form a family because all their graphs are the same. They are all a line. All linear functions are a line. Whether I slide it, move it, flip it, that's a family of function. All absolute value functions would be a family of function because all of those would make a V. So the parent function is the basic of all of them. It's f of x equals x. If it was an absolute value function, it would be g of x is equal to the absolute value of x. That's a parent function. And then there are some more that we haven't discussed this yet. A transformation is a change in position or size of a figure. In this case, we're just talking about the translation, which is a slide, a rotation, which is a turn, or a reflection, which is a flip. And we're going to talk about it in terms of functions, not in terms of like shapes or figures that actually move. All right. So if we're going to talk about a linear function and how it changes, whether there's a translation, a rotation, or a reflection, it's pretty much the y equals mx plus b. Remember, that's your bestie. Mhm. Y equals mx plus b is your best friend format of all the linear functions. It's going to be transformed to y equals m, still your slope, but that x is going to be broken into x minus h, and then we're going to have ab. That's still your y-intercept. So your slope is going to tell you how you rotate, whether it becomes steep or less steep. If it goes up, it's becoming more steep. And if it goes down, it's becoming less steep. The inside the H, right beside the X, which is horizontal, is going to tell me if I move left or right. So it's going to be a horizontal shift left or right. That's what this inside of the parentheses is going to tell me. The B on the outskirts is going to tell me how I move up or down because it's the y-intercept. So it's going to tell me if there's a vertical shift up or down and by how much. So let's break these down. If I look at number one, I'm going to go from f of x to g of x. F of x is x to g of s, which is x plus 3. So first you want to look at your slope. Is there a change in the slope in front of the x? The answer is no, because it's just a 1 and that's a 1. There is no change. The next thing we're going to look at is inside the parentheses. Is there anything inside? I don't even see a parenthesis, so I know there's not. Then the last thing I'm going to look at, so nothing has changed so far, is the outskirts, which is the b. This b is 0, and I look out here, and this b is positive 3. Therefore, I know there is a change in the y-intercept. There is a change in the b in terms of going up or down. And so I know that this is going to be a vertical shift. I'm going from 0 to positive 3. So on a number line, right, positive 3 would tell me that I'm going up. That's negative. And if it's horizontal, let's see, 0, positive 1, and negative 1. So I'm going to be going up. I'll be going up vertically 3. So it's a vertical shift up 3. Let's look at number 2. I look in the front. There is no change on the slope. The slope is both 1. I don't see a parenthesis, so nothing is going on there. And then I look on the outskirts, and then I see there is a change in the last number on the edge, which is the slope. I'm going from 1 to negative 2 because it's that last number the y-intercept up or down, I'm going to be going either up or down. So from 1 to -2, from 1 to -2, I actually have to go down. And I go down 3. So this is a vertical shift, still up or down. I'm going down 3. All right, let's look at another one. Again, always start in the front. Is your slope changing? No, so I know it's not a rotation. It's not getting steep or less steep. I got to move on. I look and I actually see that there is something going on inside a parenthesis. So this is just x. And then this one actually has an x minus 2. That's going to affect your h. I've been making the slope intercept one blue. And the first one I've been making green. That's blue. Trying to give you some colors. There we go. All right, so the pink, I know that's left or right because it's inside the parentheses. It's my H. And so left or right, which goes with my pink, right? I'm going from 0 here to -2. Oh, but remember, it's also not what we see. We got to change this thing in here as soon as we see it so we don't forget. It's a +2. So I'm really going from 0 to +2. I'm going to the right, and it's a H horizontal shift. So this is horizontal shift. Right, 2. Then I look out here. I've accounted for the inside, and my blue does not change. It's still +1. So there is no up or down movement. This is all that happened. Let's look at number 1 down below. I see that I'm going from, looking from left to right, from 3 to 5. Well, there's nothing in the parentheses and there's nothing on the outskirts. So I know there's no up or down and there's no left or right. But I am going from 3 to 5, which means there is a rotation and it's going to be steep or less steep. So if I go from 3 to 5, the numbers go up. When the numbers go up, it becomes steeper. If the numbers go down, then it becomes wider. So this is going to be a rotation up, which actually makes it steeper. Let's look at next one. I look in the front again. Oh, this is changing. So I need to know it's going to be steep or less steep. I'm going from 4 to 1/2. I'm going down, which means this is going to be less steep. From kx to g of x, that new line is going to be not as steep as the original. And then I see no parentheses, so it's not left or right. I come on out here to the blue, to the y-intercept, and the y-intercept is the same, so it's not up or down. I'm good. Let's look at number 3. And I'm going to have us do a couple, right? So let's look at number 3. I have 2x plus 3, and it's going to be changed into 2/3 x minus 1. Again, you start looking at the very front one. Will there be a difference in your steepness? Go ahead and write that down. Then look, is there anything changing about that x? Is there anything in the parentheses? Does that make a difference? Write that down. And then you want to look, is there anything changing out here on the y-intercept? Go ahead and write that down. So we should have that the green, the slope is going from 2 to 2/3 it's going down, which means there's going to be less steep. The X is not changing, so there's nothing pink. And then I'm going from +3 to -1 on the y-intercept, so up or down. From +3 to -1, I'm going to be going down. And so I'm going to go down 4. That's a vertical shift. Down 4. The next thing you want to talk about is the reflection, because the sign itself, not the number, is going to tell me when I look here on the green, I see that this is positive, same number, but negative. So from positive to negative, that creates a reflection. So if I want to know the reflection here, it's just going to be negative, because that's all that's changing. The sign tells me it's a reflection. Now the same thing is going to apply to the absolute value function, right? The A, your slope, is still going to be green. Oopsie. The A is going to be green. It's going to tell me, in this case, if there is a vertical stretch, if the number goes up, or a vertical compression if the number goes down. X minus H in the middle, I think that's the color I used. X minus H in the middle is going to tell us left or right. Left or right. And then K out here on the outskirts is going to tell me up or down. And then we're going to go through one at a time. So I want to go from f of x to g of x, right? I'm going to go, and I'm looking again at the very front, always starting at the front. My slope is 1. Oh, my slope is 2. Is there a difference? Yes. So from 1 to 2, the number goes up. That's going to mean a vertical stretch. When you stretch things, it goes up. So this one now has a vertical stretch. That's how they are changing. Then I look on the inside. Is there anything changing on the inside? I'm going from X to X. Nothing changes. I will have no left or right movements. Then I look on the outskirts. Is there anything changing from there to there? So from 0 to 3, there is a change. I'm going from 0 to 3. So that tells me something is going to be moving up or down. From 0 to 3 is up. Therefore, I'm going to have here a vertical shift up 3 units, because that one actually tells me. All right, I am going to have you pause here, and then I know it's challenging, but pause, and I want you to try number 2, 3, and 4. Go ahead and pause and try number 2, 3, and 4. All right, now that you are back, I'm going to just go ahead and highlight all these pieces. So 1, you want to look at your slopes to find out what was happening with your slopes. Did they change? After you do your slopes, you want to check on the inside to tell you if you move left to right or not at all. That's an option too. And then you're going to look on the outskirts, and this is going to tell you if you move up or down. Vertical shift, up or down. And I think I missed the number out here. Let's call this 3. All right, so let's rock and roll. We would have from 1 to 1, no change. So not open up or down. From x to x minus 1, let's change this. It's not what I see. It's the opposite. That's -4, +1. All right, so it's not what I see. It's the opposite, which means this is actually going to be a horizontal shift left to right. And it's a +1, so I'm going right 1. Then I'm going from 0 to -2. That's a vertical shift. I'm going to be going down 2. Let's look at the next one for number 3. You would have had that it went from 2 to 1/2. So I'm going from 2 to 1/2. The number goes down. Therefore, there is a vertical compression. I'm going from x to x. Nothing is changing inside. There is no left or right movement. So then I'm looking on the outskirts, 3 and 0. I'm going to be going up or down. If I go from +3 to 0, then that means I had to go down 3. So there is a vertical shift. Down 3. Let's come on down to the last one. I'm going from +3 to -1/3. Oh, so that positive and negative, just the positive and negative, is going to let me know that there is a reflection because it opens down. And that reflection is across the x-axis. I look inside the absolute value function. This is a -4 going to a +1. So -4 to a +1. That means there is a translation right 5. That's also known as a horizontal shift. It just depends on the book or which context they're in. It's a horizontal shift 5 units. Same thing. Lastly, I look on the outskirts. I'm actually going from 0 to +3. That tells me that there is a translation up 3, because this is up or down. There's a translation up 3, or because that's vertical, I'm going to call it a vertical shift up 3. I want you to hear all the terminologies because they use them differently at different times. All right, so now I want you to pause, and I want you to describe those transformations from f of x to g of x, and I want you to graph both of those functions. So you're doing this graphically and algebraically. Okay, so now that you're back, we would have seen that the graphs have been transformed. They've been translated whether up, down, left, right, vertical stretch, vertical compression. You can see it visually with the graph, and you could actually do it that way, and you can see it with the actual functions themselves. All right. Remember, to learn our mathematics, you must be sure to do the mathematics. Go ahead and pause and check your work. All done.